channel. My name is M.R.E.ngineering and today I'm going to talk about how technically an automotive air conditioning system works. As you probably know, in an AC system, we need to use a refrigerant with low boiling point, and it means that in ambient pressure and temperature, this refrigerant is in gas state. So we know refrigerant as a gas. One of the first refrigerants that was used in mobile AC systems was CFC-12 or R12, that is known as a Freon with boiling point of about minus 22 degrees Fahrenheit. But this R12 refrigerant had some major drawbacks. This gas is known to be an ozone depleting gas, and it means that chlorine content of this gas reacts with ozone gas in ozonosphere layer of the air under effect of UV rays and makes this layer weak over some areas of the earth. Also, this gas is known to have greenhouse effect that leads to global warming, and it means that presence of some gases like R12 and also carbon dioxide in the sky causes the sun rays that want to leave the earth after reflection reflect inside again, and this makes the atmosphere to get warmed up. These drawbacks made the R12 replaced with R134A or HFC-134A after 1994. R134A has the boiling point of about minus 16 degrees Fahrenheit and today is used in most of the mobile AC systems. And however, this gas is not an ozone depleting gas, but it makes a small contribution to global warming. But the United States and European governments are looking for refrigerant with less effect on global warming, and two candidates for this purpose are R744, that is pure carbon dioxide, and also R1234Y. I have plans to record a video about technical requirements and precautions for the systems that are using these refrigerants, and watching that video is highly recommended for those AC system technicians. Now, by using any of these refrigerants, we need to have a system that works in a cycle to inject these refrigerants into that, and by using an evaporator, extract the heat from interior and receive cool air from the AC system. This working system and cycle requires these main components: a compressor, a condenser, a filter dryer, a thermal expansion valve, and an evaporator. The refrigerant, after coming out of the evaporator, is sucked into the compressor. In fact, the compressor is the heart of the system and receives its power from the engine using a belt. There are different types of compressors, but all work based on the same principles. Refrigerant must be compressed, and for the systems that use R134A, pressure of the refrigerant increases from about 2 bars to about 16 bars. So the output of the compressor would be a gas with high temperature and high pressure. Now the gas is in a state that is ready for dissipating heat to turn into a high pressure liquid. This process happens inside the condenser that is just like a thin radiator. This high pressure liquid, after leaving the condenser, goes into a filter and dryer that is in form of a bottle or is integrated into the condenser. The dryer absorbs the moisture, and the filter, that is a small part of this component, filters particles that want to fly into the whole system and probably would damage the thermal expansion valve or the compressor. Here, you just remember that the output of the filter dryer is liquid refrigerant. Then refrigerant goes into the tubes to reach thermal expansion valve. In design of thermal expansion valve, engineers use rules of physics that state that when a fluid expands, its pressure drops. In the expansion valve, there is a very narrow passage that in one side there is a high pressure refrigerant, and on the other side there is an evaporator with low pressure. When the refrigerant passes this passage, its pressure drops and it turns into low pressure liquid, and in this pressure, refrigerant tends to be in gas state even in temperatures very lower than 32 degrees Fahrenheit. So it suddenly goes into freezing temperatures, and when warm air of the interior passes over the evaporator, cool air comes out of the AC system. The refrigerant, after coming out of the evaporator, goes toward the compressor, and this process continues as long as the compressor is on. Now that you know working cycle of the system, let's talk about working principles of each component. I start again with compressor. When the compressor comes on, it sucks refrigerant into a low pressure chamber. This low pressure chamber is formed by the movement of a piston or plate that is moving by rotation of a shaft that it turns by the torque that is applied by the engine power through a belt, or for electric or some hybrid cars by an electric brushless motor. When the shaft of compressor rotates, the piston or plate that caused the suction now tries to compress the refrigerant, and on the compression the inlet valve closes by a check valve. But the output valve can be opened at a pre-adjusted pressure. This adjustment of pressure is accomplished by using a spring type steel plate for on and off type compressors that are known as fixed displacement compressors. To control switching of the on and off type compressors, there is a magnetic clutch that pulls and engages the rotating pulley with the input shaft of the compressor when you command the AC system to turn on, and some other requirements are satisfied that I talk about them in this video. On the modern compressors that are known as variable displacement ones, an ECU continually controls an electric valve to control the output of the compressor. I don't want to confuse you with more technicalities and details of these systems, but you just know that controlling these systems is just by controlling the compressor, whether it is on-off type or a modern variable displacement one. Now, after the compressor, we have the condenser. Input of condenser is high pressure and hot gases refrigerant, and its output is high pressure liquid refrigerant. So you can easily understand that what happens in the condenser. In simple words, we can say that using a fan, refrigerant dumps a large amount of its heat energy in the condenser. When you request for cool air by pressing AC switch, other than the magnetic clutch of the compressor, ECU turns on the fan in front of the condenser. Almost always the condenser is located between the radiator and the grille in front of the car. A fan pushes or pulls air on the condenser, and this passing air absorbs the heat from that, and the phase changing happens for the refrigerant. In most of the AC designs, after the condenser, there is a filter dryer. This filter dryer is there to not let the moisture and particles to go into the system. To absorb the moisture, dryer uses desiccants, and its design is so that only liquid refrigerant can pass into the system. Next component is the thermal expansion valve that is located just before the evaporator. There are many designs for the expansion valves, but all work based on the same principle. Based on this principle, output of the expansion valve depends on the temperature and pressure of the evaporator output. In some older designs, you can see a capillary tube on top of this component, and this tube on the other end is connected to the output pipe of the evaporator, and this design senses the temperature of the evaporator output, and this temperature adjusts the pressure inside the chamber in the valve cap, and pressure change of this chamber moves a pin that is in contact with the diaphragm of this chamber, and movement of this pin regulates the size of a passage that is considered as the entrance of the evaporator. But modern valves don't have this tube on the outside, but the evaporator output passes through the valve and adjusts the size of the outlet for the expansion valve. Now I want to talk about another design for mobile AC systems that is less common, but maybe your car's AC system is based on that. Overall function of that system is the same with this system, but the only difference is about filter dryer and the expansion valve. In this design, a filter dryer is not used, but after the evaporator, we have an accumulator that receives output of the evaporator and gives out only gaseous refrigerant, because liquid refrigerant can damage the compressor. And also the expansion valve is replaced with an orifice tube that its hole size is always fixed, so the output of the evaporator only relies on the cycling of the compressor clutch. And finally, the evaporator, that, as the name implies, its job is to evaporate the low pressure liquid refrigerant that comes out of the expansion valve, and this component is not visible from outside because it is located inside of your car's dash. At least 3 air channels are connected to the chamber that the evaporator is located in. One is for the input air from the AC fan, and the 2 others are the outputs, and they are separated from each other using a damper. One of these output channels guides the air to pass over the heat exchanger to make the air warm in cold conditions, and one channel bypasses the heat exchanger so the heating system doesn't affect the output air of the AC system. Also, before the AC fans, there is a damper that makes it possible for the system to change source of the input air from the fresh air of the outside to the used air of the inside, or vice versa. By selecting recirculation mode, the door moves from the outside source to the inside. Modern cars can adjust and mix these two sources for greater comfort and windshield defrosting. Please note that if you want maximum cooling in hot outside conditions, you should select recirculation mode. Now I want to talk about more technical issues like controlling air conditioning systems and their logics. I know that some guys don't like to watch these technicalities, but I have tried my best to make a simple presentation that won't make you bored and exhausted. So please stay on and keep watching. There are two types of controlling air conditioning systems, manual and automatic. And of course, in transition from fully manual to fully automatic systems, there are some types that are called semi-automatic systems. And I think if I can explain manual and automatic systems in perfect, I can sum up the semi-automatic types in a few sentences. In manual systems, you can adjust temperature, humidity, and air flow rate by turning on the AC system and adjusting blower fan speed and changing modes. But in the automatic systems, you only need to turn on the AC system and set in temperature, and a computer manages the remainings for you. So look at your car's AC panel, and if it has the provision for setting temperature, your car's AC system is automatic type. And also in manual systems, guiding the air and opening and closing the dampers is done by cables or maybe actuators, but in the automatic types, this opening and closing is done via electrical commands and servo motors and actuators. Now, if I divide the whole system into two sections of under the dash and under the hood, I think you know the details of under the dash for manual systems if you have watched this video up to this second. Only things that I want to add here are AC on button and blower fan speed selector that are part of the electrical power for compressor clutch and condenser fan. And it means that by commanding AC system to switch on and selecting a blower fan speed, compressor clutch, condenser fan, and under the dash blower fan will switch on. But to understand the function of these components and switches, you should get familiar with controlling circuit of your car's AC system. But before I start to talk about circuits, I want to make a key statement. Generally, we can say that manual systems use pressure and temperature switches on their controlling circuits, but the automatic types use sensors to sense the pressure and temperature of lines and components and report that to a computer, and that computer regulates compressor and fans that results in desired output. And also consider that the automatic types also use pressure safety switch on the lines or a pressure safety valve on the compressor to protect the system in the case that controlling system doesn't accomplish its mission. Now, as I said, manual systems use switches on their controlling circuits, and they connect or disconnect electrical power for compressor clutch and condenser fan. Some of these switches are controlling switches and some are safety ones. Controlling switches like AC on button and blower fan speed selector on your car's AC panel, and another controlling switch is thermostatic switch on the evaporator that senses the temperature of the evaporator and protects that against getting frozen and iced up, and if this situation happens, it opens the electrical circuit for compressor clutch until the evaporator gets unfrozen and its temperature is back to about 30 degrees Fahrenheit. Also, on the lines, there are some pressure switches that protect the system against going the pressure more than the safe operating pressure of the system or dropping very low, as this very low pressure can be caused by a low refrigerant flow in the system that can be detrimental to compressor. For this purpose, designers use 2 or 3 pressure switches on high and low pressure lines, or they use a single multi-pressure switch on high pressure line that on some models, mid pressure of this multi-pressure switch activates high speed operation of condenser fan. Now I think you can understand overall function of controlling circuit for a simple manual AC system. In brief, I can say that electrical power for compressor clutch flows from battery and goes into a few fuses and relays and then passes through some switches that are laid in series configuration in controlling circuit to protect the system. These switches are AC on button, blower fan speed selector, thermostatic switch on the evaporator, and pressure switch on high and low pressure lines and components. Now I want to talk about fully automatic air conditioning systems. As I said, in the automatic systems, the switches are replaced with sensors, and only thing that you need to do is turning on the AC system and setting a temperature. But these systems, based on design, require some additional sensors to evaluate comfort condition of individuals that are sitting in the car. These sensors provide information about outside condition, heat load of the sunlight, and temperature and humidity of different zones of interior, and also amount of particles and impurities in incoming fresh air. Also, these systems have an exclusive ECU that works on a network to receive information about engine coolant temperature, engine speed, vehicle speed, and also receiving commands from some remotes that are sent to activate the AC system before the driver comes to the car, and also receiving digitized voice commands that are processed by the body control module to activate and regulate the AC system by the driver. And on the other hand, the ECU controls and commands components like blower fan and servomotors and actuators for dampers to provide and guided condition air to different zones of interior based on their demand, and also regulating compressor to optimize energy consumption and regulating condenser fan for optimum heat dissipation. And however, may there be more sensors and components for some designs, but I don't want to confuse you with more technicalities, and I think now you can understand overall function of these fully automatic air conditioning systems. For semi-automatic systems, some of the components and sensors are the same with fully automatic systems, but these systems always depend on occupants' commands to adjust the blower and changing modes that results in desired output. Also, in these systems, ECU monitors the whole system and controls relays, compressor, and condenser fan. Now, I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like, and press the bell icon to be notified if I have a new video on my channel. Bye.